Hello everyone. This class is for grade 11C core. Okay, we're going to continue from the last lessons, which is we learned about real numbers. Okay, and this lesson gonna learn about the ordering real numbers. Okay, it's still in the real number topics. Okay. So first of all, we're gonna take a look at the definition of order on the real number lines. Okay. Say if we have if A and B are real numbers, A is less than B if B minus A is positive. In this case, that means we know if A less than B, we can write the symbolic inequality sign become A less than B. Or you can say that means another word is what? B greater than A. Okay, so if we have A, we write in this symbolic. How we read it? What the meaning? Mean A is less than or equal to B. A is less than or equal to B. And this case, the same thing. If we have B, we write it down in this side. We're going to read it as B is greater than or equal to A. So then we're going to use greater than sign or greater than equal, less than or less than equal to read the real numbers, okay, on the number line. For example, if I give you, say, the example, when I give you comparing, right, on the number line. For example, say I have -3 and 0. So this one, of course, everyone know right away. Okay, of course, right? Everyone know which one is greater than the other. So if I put a number line, okay. So you can see our 0 assumed right here, and -3 may be here. So you know, then we know right away our -3 must less than 0, right? How we know? We can see every number on the right hand side. Right now we have -3 and 0. 0's on right hand side. 0 gonna greater, the value of 0 greater than the number on the left hand side. Okay, so that we have this one less than 0. Okay, see more example. If I give you, say, if -2, we review. Okay, I think this is still in the reviewing chapters. Okay, now we see this one. Okay, come back here. So -2, -4. For example, this should be in the left hand. This assume 0 right here. Okay, so our -2 should be here, right? And -4 should be here. So now you observe our which one greater than between these two numbers, -2, -4. So you see which one on the right hand side, -2, correct? And this on the left hand side. So we know right away our -2 greater than -3. So we have right away -2 greater than -4. Okay. How about if I give you like a 1/4, like a fraction, right? Over 1/3. Okay. See if I compare on the number line, right? So negative 1/4 and 1/3, which one you convert? 1/4, if you convert to decimal, equal to what? 0.25, right? But this kind of number terminating decimal, right? And 1/3 is approximately 0.3333, right? Okay, it's a repeating decimal. This in the rational number, everyone still recall? Okay, now see, we can compare. Both of them positive. Assume my 0 right here. Okay, which one should come first? 0.25, right? And next gonna be about 0.33. Now, when you convert to decimal, you know right away which one less, which one more. So in this case, we have right away is what? Our 1/4 should be what? Less than 1/3. Okay. Now, if from this number, if I like as the negative sign, okay, this one, if I say from negative 1/4 and 1/3, if I like become negative 1/4 and negative 1/3, which one less, which one more now? This one. Okay. Okay, so this one gonna be opposite from here, correct? Because if our zero right here, negative 1/3, we already have right now become, okay, this one 1/4 is, we know is a 0.25, right? And this one become negative sign, and this one gonna be 0.33 that have negative. Okay, so this one gonna be 1/3 right here, and this one is a negative 1/4. So you compare which one on the right hand side, this one, right? So we know right away this one should be less than negative 1/4. Or can say this one greater than this, or can say negative 1/4. Negative 1/4 is what? Greater than negative 1/3. Okay, so this is talk about ordering real numbers. We have to know a number on the number line, which one greater or which one less. There is kind of comparisons. Okay. So another word here, you see from the number on right hand side greater than the number on left hand side. Another word you can see, if negative of any larger number always less than the negative with the smaller numbers. It's another way to see. Okay. So now we go more about interpreting inequalities. Any question so far? Okay, right? Okay, we go next one. See this one. For the interpreting inequality. So for example, I give you more example here. But now it's in interpreting inequalities. Example, say if I give you this one, x less than, right? We read, remember how to read, just say if I like in this way, what the meanings. Okay, this one mean what? All real numbers less than all real numbers x, right? Less than or equal to 2. Okay, when we read this one, become all the real number. All real number will be like that. All real number. All real number x, we can say all real number x, right? Less than or equal. Or it's a A, okay? It's a L. Erase it. Or equal to 2. Okay, so how about one more? Say if I have here x less, I like this way, and we're gonna read it out how to read. Okay. So in this case, we call double inequalities. Why? Because we have two inequality. One is this set on the right hand side. Okay, on the right hand side here. And another one on the left hand side, this set. Okay. So so we can make it down, become say negative 2, right? This one, like in this way. And we use and, okay? Because this is an and. Then we have x less than 3. So if we read the whole thing, how we read x less than 3 and x greater than or equal to -2, if we read the whole thing. Okay, so that means, one more time, how we read the whole thing: x less than 3 and x greater than or equal to -2. Okay, in this case, -2 we include number, we include parts of the solution, but 3 here no equal sign here, right? So 3 doesn't include, 3 is not a part of the solution of this inequality. Okay, so in this case, if we draw, okay, number line, see what we have. If we draw a number line, we draw a number line here. Okay, this is an example too. Okay, so when say how you plot graph on the number line, we have two ways to plot graph on number line, because this one x, for example, this is 0 right here, assume right here. Okay, maybe I use another color can help. So we have 0 here, and then 3 maybe about here, right? 3 and 2 here, -2. So we can draw first way, we can, because this is include, you see have equal sign underneath, that means include the -2. -2 is a part of solution. So because have equal sign, then you can write this side, close it up. This side represent closed interval. And because under less than sign here, no equal sign underneath. So this one is open. So you can write it as open like this. This represent open sign. Okay. And after that, you have to draw one line, the whole thing. You can draw the darker colors or draw another color underneath here. Okay, so the pink color here, this is a solution, the final answer for this example. Okay, or another way you can represent on the number line, because this close, so you write it down as a back dot here. And because 3 no equal sign underneath, so you write with the open dot. And then you draw one line, join the line up. Okay, so this either way you can draw like this pattern, or the second one on the x-axis or number line. Okay. Any question? For the example 1 here, let me see. This one, okay, example 1 here. Once you know this one, how we represent on the graph. This one, right? If x less than and x less than or equal to 2, how you draw the graph on the number line represent by. Okay, so because say 0 here, so you to assume here, but because they have equal sign, right? So you can like close like this, and then maybe I use another color, right? Okay, maybe I use yellow. So you like close down here, close sign, and you draw another color, back dark color, or another color represent. No, it's not straight. It should be straight one. Right? Okay, we draw one more time. So this one gonna be close to here, because 2 have equal sign underneath, and then you draw one dark color and represent with the arrows. Okay, another way you can draw is, because this is include, so you write back dot, and then you draw one line here. Back dot here, and then you draw one arrow. Okay, so this is another way to represent for example 1, and this one, the pink one, represent example 2. So let's talk about the interpreting inequalities. Okay. Now we see this one, the conclusion for the interpreting inequality. Take a look at this one. Okay, everyone see this one. Okay, see this one on. We can conclusion about this one for the inequality on the number line. We can say also it's a bounded or unbounded. For bounded is, you can see the notation. If they're close, you see on here is a close sign. Okay, so this one we call close interval and represent with the graph number 1 with the close interval. And if open here, both sides, they call it open interval. We will represent it with this sign, like example we just finished. And then this one also, one side closed, one open. So we cannot conclusion that it's open and also we leave it blank here. And at the same time, like this example also. So, but anyway, in this case, if you have closed one side or closed both sides with the number, end with the number, we call this a bounded interval. And when we're gonna call it unbounded, that means we talk about infinity similarly. Like this one, close A, go up to plus infinity. Because we have open here, infinity have to be open for sure, right? Cannot be closed because go infinite number, infinite term, so have to be open symbolic. So this one, if you see the infinity sign, we count this one as an unbounded. And you can see the example below. It's going to be open because both sides open. So we interval type is open. And this one open, one closed. So in interval type, we cannot conclusion, so we leave it blank. And then you see the graph represent for each one. Of course, this one, the both side open. Okay, and then the arrow go to both side left and right. This represent unbounded. Okay. Any question? And this one, this handout I will give to you, like this page, so you can review one more time after our class. Okay, we go next example, I think. I write down here. If I say C is at most 2, so what the meaning here? Okay, so SC is at most 2. If we want to write as a notation or interval symbolic, how to write down? At most mean maximum. So that our maximum is 2. Then less than 2 is okay. To negative infinity, right? So we can say our C, we write in this way, the symbolic. C less than or equal to 2. Okay. And in this case, if you want to plot graph, okay. When you plot graph, you can see because 2, right? For example, our 0 right here, 2 here. Because less than equal to 2 and have equal sign underneath. So this one must be equal. We write back dot. And write back dot and move one line to the left hand side. So that's the represent C. C is at most 2. Okay, right now we talk about real number. Okay, so we'll draw all the whole thing with a dark line. Okay, now we take a look for next example. Say M is at least, M is at least negative 3, for example. At least, what the meaning at least? that means the minimum, right? So that you can go above 3, I mean go above -3. So your symbol is gonna be m greater than or equal to -3. When you put on the number line, when you plot graph, okay, when you plot graph, say our zero right here, negative assume right here, because greater than, right? So, and that equal sign, have equal sign also, you see this under the sign. So you should include like the back dot and go up to infinite term or infinite numbers. This is a back dot. Okay. So this is a represent for example 2, this example 1. Okay, now go next one, more example. Three example, the third one. If say all x in the interval or x in the interval say if I like in this symbol. Okay, this means our x, right, is our x are between -3 and 5. So we can write at the interval or notation sign as say, can write down as say x less than 5 and x greater than or equal to -3. So we can write for the graph on the number line. See that what we have. So see, assume zeros right here. Our 5 may be here. Our -3 may be around here. Observe 5, right? 5, x less than 5, no equal sign. So at 5 should be open dot. And this one, -3, have equal sign. So this one should be back dot. So then we draw the number line. So this represent this expression, this word, x at x in the interval, and like in this way. Okay. So if this one, I'm wrong here, should be, I change here. Okay. This one should be open and this one should be closed. It's correct here. Sorry, should be here. This open and this one closed. Okay. Just can match to this one. Sorry. Okay, this one. This one should be closed and this one should be open. Okay. And next, I think this is about the, maybe try more example and then we can go the absolute value. More example, okay. So example 4 now, these are 3. For example 4, if I have -1, 0, okay. This one, this interval, how we read it out, we can say all real number x are greater than -1 and less than 0. Okay, we can say all real number x are greater are greater than -1 and less than 0. Okay, so in this case, you want to draw the graph on number line. How is it? Okay. Both open, correct? Say my 0 right here, -1 right here. Both of them open, so you just like open for both sides here and draw one number line. So that's the represent these questions. So we can list say x less than 0 and or equal to -1, and x, just say x less than 0. Okay, x less than 0 and greater than -1. How about here one more example? One more example, say here. If I have like this, and this is infinity, open. So what this means, what? All real number x are greater than or equal to 2. Okay, we can say all real number x are greater than or equal to 2. So if you draw on the number line, okay, again, 0 here, 2 here, 2 includes, so 2 become back dot, and draw all around to this side, to infinity. Infinity, of course, don't forget this have to open. In this case, we call unbounded, right? Because we have infinity here. And this one we call open, or can say unbounded also. This one unbounded because they're open both sides. And this one also unbounded. Okay, once they have infinity, that means unbounded. Every time, no matter one side closed, one open, or okay, or opens. Okay, now I think that's all for the interpreting inequality symbolic. Okay. This one should be equal to 2. Should be equal to 2. Okay, so next one we're gonna go, the last topic is absolute. Come to absolute here. Absolute value and distance. The absolute value of a real number is magnitude or distance. Or distance. Okay, between the origin and the point representing the real number on the real number line. We have the definition of absolute. say if we have absolute A, we have the two conditions. If absolute A equal to A if our A greater than or equal to 0. If absolute A equal to negative A if A less than 0. Okay, this is a definition of the absolute value. Then see example, okay. Say if we have, for example, have absolute negative 16 like this. This one gonna be equal to 16, right? Why? Because inside here is the x. Just say like now inside here like a here, right? It's a negative. So actually we have like a negative here from the negative side, and then because inside is a negative, so you write it down become this one. So this minus this is 16, okay? Minus time may not become plus. That's why you got equal to 16. Okay, if we have absolute 3/5, something like this, this is gonna equal to 3/5. This one match to the first case here because our A is greater than 0. The first one here is our A less than 0. So you should have minus. This minus mean this minus. Negative side here mean this negative. And because our A negative. So see one more. If I have negative 2.6, for example, this again, this case is our A negative, right? So should in this case, that mean our A less than 0. So you're gonna have negative side from the definition first, and you take it out with inside negative A. That this question equal to negative 2.6. So then negative times negative come out become plus. So your final answer gonna be 2.6. Okay, this is a definition of and some example of absolute value. Now see more example. I think I'm gonna be a few more example, 1 or 2 more. See more example here. If I give you say evaluate this one. Absolute x over x. Okay, so absolute x over x, say if I want you find out when question first one a x greater than 0 and b when our x less than 0. So our solution is see the definition of absolute value. The question A say if our x greater than 0, right? So from this question, so our x should be this condition, correct? Become plus. So this is going to be x over x, right? Because greater than means positive. If you draw number line, can I draw here? Number line, that means, for example, 0 right here. That means everything is go to this side. So that's why this is a positive. This is a 1, right? This side connected 1. So x greater than 0, that means go to the positive real numbers. So then this is going to be equal to 1. How about the second one? If our x less than 0. So they're going to be go this side, right? Cross to this side. So become negative. In this case, going to be what? Going to get to the second definition here. When x less than a less than 0. So this is going to be, that means our x inside should be negative, right? So we have see like this, is step by step, negative x over negative x. Represent here because if x less than 0 inside here, the absolute x should be negative sign. And negative here from the definition negative here. And then over x, because x less than 0, our x should be negative side because gonna come to this side, right? When you draw number line, this is a 0, this is a 1. So negative 1, negative 2. So our to this side, this is our x represent less than 0. Okay. So from this one, you're gonna have plus plus become minus become plus, so you have x over negative x come out become equal to -1. This is a final answer. So that means when x less than 0, final answer you got this one. But when x greater than 0, your final answer going to be +1. Okay, that's the definition of absolute value and then some example right here. Okay, the next one gonna be the last topic for today. It talk about the properties of absolute values. Okay, let's see. We have 4 properties of this one. First one, if we have, let's see, maybe change to this color, pink color. One, right? If we have absolute A will greater than or equal to 0, and 2, absolute negative A equal to absolute A. This one is greater than equal sign, okay? And third one gonna be absolute A times absolute B equal to absolute A times absolute B. Okay, and the last one, the fourth one, gonna be division absolute A over absolute B. So this gonna be equal to absolute A over absolute B. The condition is, of course, B shouldn't be 0. Shouldn't be 0. So the next one, this is the 4 properties of absolute values. The next one we're gonna see, find out the distance. Find the distance between 2 points on the real number line. The definition of the distance of 2 points of real number line is right here. Say if let A and B be real numbers. The distance between A and B is right here. This is a formula. This is a formula of the distance. Okay. So that means if you want to find distance between A and B, you can use absolute B minus A, or either one, absolute A minus B. What the meaning is, see, take a look. If I draw on the number line here. Okay. Draw a number line here. So, the example gone. It's okay. So now see, if I have B, my B is here, my A is here. So you can use A minus B or B minus A, the absolute. So that can be either way. Okay. So that means say if another way is if you take A as the original point or starting point and B is a destination point, so you can use, normally we use a destination minus the original. So you can use B minus A. Or you take this starting point and this destination point, so then you use A minus B in the absolute sign. Okay, now come to see this one. If say the example find the distance. Okay, so I write down find the distance between negative 25 and 13. So in this case, you can see, for example, say assume my A is a 13 and B is a negative 25. So either way you can do like a beginning according this example, the definitions. So if say you want to get say this original point is a destination point, so you can start with negative 25 minus the original point here. So we become absolute negative 38, and then this one gonna equal to absolute 38. So you just can write down right away here. So this one gonna be 38. Okay, so this go to our absolute definition. The beginning we have, right? Have two situations. Absolute x will equal to x when our x greater than or equal to 0, and equal to negative x when our x is less than 0. So this condition is matched to our second one here, because our x negative, so come out negative times negative, so you got plus, so you have positive 38. So otherwise you can use, then now you use b minus a, then if you can use a minus b, okay. So a minus b, that means right now this one become destination point. So that's a minus b. So you have 13 minus 25, negative 25, and then absolute here. So inside absolute minus time become plus. So you have 38 absolute, and then equals to 38. So this case same with the first condition here. Okay. So come out become plus. Okay, so is about the topic today we learn. So how about with conclusion? Beginning we start with the still under the topic of real numbers. But today we do the first one, we talk about the ordering numbers, right? Ordering real numbers. The first one. The first one, ordering real numbers. We talk about what? On the number line, right? On the number line. We compare between two numbers, which one greater, which one less than to each other. We take a look on that. That's ordering real numbers. And second one, we interpreting inequalities. That means we can give you like a, say like a x less than or equal to 3, how you lead, right? And we plot graph on the number line, what are the representing the interval of this one. That's the number 2 question, topic number 2 we learn. And third one, we took take a look on we learn about the bounded or unbounded intervals on the real numbers, on the real number line. Okay, so for example, conclusion say if we have open a, b, something like this, a, b is a real number, or even you have something like a close a, b, right? A, b is a real number. If this one is a bounded interval, because you will, no matter you open or close or either side with the number here, so it's a bounded interval. But fourth one, if say not, it's under here number 3. So if you have open, for example, a and to infinity, right? So if you have with the sign infinity sign here, this one we always call this unbounded, okay, with the sign infinity, okay, become unbounded intervals. And the last one, the last one topic we do, just mean today we doing right now, the properties and find the distance of the absolute value. That's the last one. Okay, this is about the idea we learned today. Again, I will give you the handout for these lessons, and you can review and study one more time for the example on the definitions. Again, if you, I will give you some question to practice. If you need any help, please, we have the Line group, or we have the website, the school website. You can ask from that one also. Okay, I think, hope you understand the lesson today, or hope and you enjoy about our lesson also today. Okay, I think that's all for today. See you next class. Okay, bye bye.